Question 22. Describe the change in the wavelength of a wave when the period is reduced by 1/2. This is another ratio question. First of all, you need to see what parameter changed and what's the relationship between the new and the old parameter. So you can see here the period was reduced by 1/2. That means that the new period is equal to half the old period. Now you will see what is the effect of changing the period on the wavelength. So we need an equation that has both wavelength and period in it. We go to the list of equations we have. We know that wavelength lies in this triangle, v equals to lambda f. So lambda is v, the speed, divided by the frequency. But this equation has the wavelength, but it doesn't have the period. So what am I supposed to do? I need an equation that has both the variable that changed and the variable at which I want to find how it changed due to the change of the other variable. Here, remember that the frequency is linked to the period using this equation. So I can substitute its equation, and you can see that we create another equation that links between lambda and t. So lambda is equal to v divided by 1/t. I substituted instead of f, I put what it equals to, which is 1/t. So that means that lambda equals to v multiplied by t. Remember, division turns into multiplication. So this is the equation that links between lambda and t. Lambda is equal to the speed multiplied by the period. So this is the old equation. The new equation, the new lambda, the new wavelength, is equal to the speed. Nothing happened to the speed. And you can see the question didn't change the speed, it only changed the period, so it's the same speed. Although the period changed, so v multiplied by the new t. Now you can substitute the new t in this equation. So the new lambda is equal to the speed multiplied by half 0.5 t. There you go. Now you need to divide these two equations, this one and this one, over each other to find the ratio. The new wavelength divided by the old wavelength is equal to v multiplied by 0.5 t divided by vt. You can see that there's a couple of variables that will cancel, and we're left with the relationship between the new and the old periods, the new and the old wavelength. The new wavelength over the old wavelength is equal to half. Multiply or cross multiply, the new wavelength is half the old wavelength. So this is the general way of finding a ratio, creating two equations, one with the old parameters, one with the new parameters, substituting the variable that changed in the new equation, and then dividing the two equations, this one right here and this one, over each other to find the ratio between the new and the old wavelength. Of course, there's another way of finding this, which is seeing what number entered the equation. So this is the equation that links between wavelength and period. You can see that the number that entered is half. The period now is half its amount. We can write here half. Or maybe you can write it all over again. I'm doing this just to create. So half ft. So this is the new wavelength. So this is the number that entered the equation, half. خلينا نحطه في البداية. Let's put it at the front of the thing. Is equal to half. Then, VT. So the new wavelength is equal to half. You can see that this is the old wavelength. So this is another way to find the ratio. Just see what number entered the equation here. The number that entered the equation is half. Right. Okay, right.